A function f is said to be differentiable at a point x if it is continuous at x and if the derivative exists at x. Okay, so those two things have to be true. Just a minute. I want to make sure I say that correctly. Sometimes I can word it wrong. I don't want to word it wrong. So basically, if it's said to be differential if the function is continuous at x and the derivative of the function is continuous at x. So remember continuity, when we talked about continuity, a function was continuous if you could draw it without lifting your pencil. Well, the requirements for differentiability are stronger than that. Not only do you have to draw the function without lifting your pencil at the point that we're talking about, you also have to, there can't be any corners or breaks. It has to be smooth, okay? So in addition to being continuous, it also has to be a smooth curve. Well, what do I mean by that? So let's just look at some examples, and this will shed some light on this idea of differentiability. So here we have a function, it's a hyperbola, and notice the curves for this function are smooth. Okay, so that's not a problem. However, there's a break at x equals 0. Okay, so this function f is not differentiable at x equals 0 because f is not continuous. At x equals 0. All right. So now let's look at a function here where it's continuous. In other words, I can draw this without lifting my pencil. However, it's not smooth. Right there, we have a sharp point, and that means it's not continuous at that point. So we'll just give that point a name. On the x-axis, we'll call that A. So our function here, f is not differentiable at A, okay? And it's because of the corner, because it is not smooth. So the derivative at A does not exist. okay? Or I should say the derivative at A is not continuous. That's what I meant to say. Sorry about that. Okay? So in order for it to be differentiable, both the function and its derivative must be continuous. So basically, what is differentiable? Well, it would just have to be a continuous, smooth curve, right? Like this. Polynomials are differentiable everywhere. Incidentally, another example. So here we have a curve that's smooth, okay? But it's not a polynomial because it has a hole in it. So, and here's my A. Because F is not continuous at A. Okay. Any questions about that? So here we can't draw it because of the hole. We have to lift our pencil. So it's not continuous, therefore it's not differentiable at A. Everywhere else it's differentiable because everywhere else it's continuous and smooth. But there's the sticking point right there. Okay. So corners, breaks, and holes are not allowed for differentiability. So for your homework, let me just take a peek at that for a minute. And kind of see. The question says, list the points in the graph that are in this interval from -2 to 8 at which the function is not differentiable. So you can kind of see here from -2 to 8, we have, it's going pretty good here. It's smooth and continuous, but then right there we have a point. It's not smooth. So it's not differentiable at 2. And then we're going along, we're doing just fine. But then we get here to this hole here, which is down here. So that's not differentiable at 4. And then you're coming along here, you're just fine until you have a break there. So it's not differentiable at 6. So the offending points on the x-axis. Remember now, when you're talking about qualities of a function and you're saying where, you're always talking about x values whenever you're locating where something happens. So to find an x value, you draw a vertical line. So here's the bad spot. I draw my vertical line. It hits 2. Here's the bad spot. I draw my vertical line. It hits 4. And here's the bad spot. My vertical line hits 6. So 2, 4, and 6 are the location of where differentiability fails the test there, okay? So you're just going to list, it says use a comma to separate your answers. So what did I say? 2, 4, and 6. Here's another problem similar to that one. Here you just check the boxes where the function is not differentiable. So this is fine, right? There's no break or hole, and it's smooth there. So this one's fine. This one's also fine. But everything else, here we have a break, here we have a hole, here we have a sharp corner, here's a hole. So 1, 2, 3, and 4 all fail the, I'm sorry, not 1. Yeah, that's 0. 1, 2, 3, and 4. Okay, so that's how you do those problems. This problem is asking you about tangent lines. And remember, tangent lines, they're allowed to touch but not cross. So here we have a line that's crossing. Here we have a line that's crossing. So these two are the ones that are not tangent lines. And that pretty much covers everything we're going to say about differentiability. And that concludes section 1.4.